In this lesson, we're going to discuss factoring a sum or difference of cubes. To understand this, it is important to know your cube facts. So you might want to take note of what these are. 2 to the third power is, I'm going to change colors, 8. 3 to the third power is 27. 4 to the third power is 64. 5 to the third power is 125. 6 to the third power is 216. We can go one more. 7 to the third power is 343. These numbers, I almost forgot the most important one. 1 to the third power is 1. These numbers are important to keep in mind. At the top here, you'll see there are formulas for the sum of two cubes and the difference of two cubes. Sum of two cubes meaning we are adding two cubes together. Difference of two cubes meaning we are subtracting two cubes together. So if we have x to the third plus 8, I don't have two cubes here. I need to figure out, I see this is a sum, but I need to rewrite 8 in terms of cubic form. Well, if you remember here, 8 is equivalent to 2 to the third power. So I can rewrite this as x to the third power plus 2 to the third power, and now it matches my sum of cubes perfectly, where x is in place of a and 2 is in place of b. So this is going to become, it says x plus b, or a plus b, so that's going to be x plus 2. And then we've got x, a to the second power, well, a is x to the second power, minus a times b. Well, a is x, b is 2. We don't usually write x2, we usually switch that around and write it as 2x. And then we've got plus 2 to the second power. That we know, so my final answer is going to look like this. X plus 2 times x squared minus 2x plus 4. We're done. Next example. This time we have a difference of cubes, and we need to figure out how we can rewrite 64. If you look at our early note sheet, 64 is equivalent to 4 to the third power. So I'm going to write this as x to the third minus 4 to the third. And now I can start filling in my x's for the a's, my 4 for the b's. So we've got a minus b, well that's going to be x minus 4, times x to the second. Multiply them together, we have plus 4x plus b to the second. If you just want to do 2 to the second or 4 to the second right away and get 16, you may do so, and there's your final answer. These are the two easy examples. Now I'm going to show you two harder examples. Now we've got 8y to the third minus 27. We need to split this 8y to the third. Well, 8 is the same as 2 to the third. Then we've got y to the third minus 27. Now there's a property of exponents here that says we can write 2y in parentheses, raise it to the third power. It is the equivalent of 2 to the third times y to the third. But now we have 2y to the third, that's for our a, minus 27. 27 was 3 to the third. So now my a is 2y and my b is 3. And we have a difference of cubes, so this is going to be 2y minus 3 times 2y squared plus 2y times 3 plus 3 to the second power, which is 9. So here I got to rewrite this. 2y minus 3 Now, 2y to the second power, that's going to be 4y squared, plus 3 times 2 is 6y, plus 9 in the end. Last one. 5x to the fourth plus 40x. I see a GCF out of both of these. I can divide them both by 5, and I can take out an x out of both of them. So if I divide 5x out of 5x to the fourth, I'm left with x to the third. If I divide 40 by 5, I'm left with 8. I took an x away, so now we've got x to the third plus 8 in the middle. So 5x stays out here. We have x to the third plus 2 to the third. We've done this one before. So 5x is going to equal, or 5x times, when I rewrite this, we have a sum of cubes. So we have x plus 2, x squared minus 2x plus 4. And that is my final answer.